Hello guys, this is the EdExcel AS level maths paper 1 from the June 2019 series, so let's get straight into it. So for question 1, we have the line L1 which has equation 2x plus 4y minus 3 equals 0, and the line L2 which has equation y equals mx plus 7, where m is a constant. Given that the line L1 and L2 are perpendicular, for part A, we have to find the value of m. Well, over here, if we put this line L1 in the form y equals mx plus c, then from this we can find the gradient of the line L1. So, for part A, we have over here the line L1, which has equation 2x plus 4y minus 3 equals 0, and if we rearrange, 4y is equal to minus 2x plus 3, and if we divide through by 4, we can see over here y is equal to minus 2 over 4, which is minus 1/2. So we have y equals minus 1/2 x plus 3 over 4. And what can we say from here? Well, it becomes quite obvious that the gradient of this line L1 would be minus 1/2. So let's just write that down. The gradient of the line L1 is minus 1/2. Okay, so with that being said, if we consider this line L2 has equation y equals mx plus 7, we can first of all use the fact that L1 and L2 are perpendicular to each other to find the gradient of L2. So, we can do so by finding the negative reciprocal of minus 1/2. So therefore the gradient of the line L2 is equal to minus 1 over minus 1/2. And if we work out this value, we have 2. And knowing that the gradient is 2, which corresponds to this m, we can conclude over here m is equal to 2, and therefore we can conclude that we have an equation for L2 which is y equals 2x plus 7. Now, for part B, the lines L1 and L2 meet at this point P, and we have to find the x-coordinate of P. And we can do so by solving a simultaneous equation between this equation, we'll call it equation 1, and this equation over here, we'll call it 2. So with that being said, if we set equation 1 equal to equation 2, what we have over here then is, well, we have minus 1/2 x, so let's just write that down, minus 1/2 x plus 3 over 4, and this is equal to 2x plus 7. Okay, and if we rearrange, well here, if I add a half x to both sides, we end up with 2.5x. So 2.5x equals 7 take away, well here we have 3/4 take away 7, which is minus 6.25. So we have 2.5x, which is equal to minus 6.25. X is equal to minus 2.5, and therefore the x-coordinate of P is equal to minus 2.5. Okay? For question 2, we have to find using algebra all the real solutions to the equation for part 1, 16a squared equals 2 times by the square root of a, and for the second part, b to the 4 plus 7b squared minus 18 equals 0. Well, for the first part, What we have to do over here, well, we have on the left hand side 16a squared, and on the right hand side we can rewrite the square root of a as a to the power of a half, or a to the 0.5. So we have 2a to the 0.5. And if we rearrange, on the left hand side what we have a squared over a to the power of 0.5, and this is equal to 2 over 16, which is 1/8. So, using the laws of indices, a squared over a to the 0.5, that would be a to the power of 3 over 2. So we have a to the power of 3 over 2, which is equal to 1 over 8. And therefore we can find out the value of a by raising 1/8 to the power of 2 over 3. So a is equal to 1/8 to the power of 2 over 3. So what we have over here then is the cube root of 1/8, which is a half, and then squaring that we have a quarter. So therefore a is equal to 1/4. And for the next part we have b to the 4 plus 7b squared minus 18 equals 0. And the way we attempt such a question, we make a substitution. For example, if we let another variable, say t, if we let t equal, well, here we have b squared. If we let t equal b squared, then we have over here b to the 4, which we can rewrite. I'll just write it over here. B to the 4, that's b squared squared. And then we have 7 lots of b squared minus 18, and this is equal to 0. So here, if we let t equal b squared, we have t squared plus 70 minus 18 equals 0. So with that being said, we can factorize this as a product of two linear brackets. We have over here t plus 9 lots of t minus 2, which is equal to 0, from which we see t is either equal to minus 9 or 2. And if t is equal to minus 9 or 2, we can therefore say from here that b squared is equal to minus 9 or 2. But over here, it becomes quite obvious that b squared equals minus 9 has no real solutions. Okay, we can't square root a negative number, and therefore the only solution is b squared equals 2. Of course, square rooting both sides, b is equal to plus or minus the square root of 2. For question 3 part A, given that k is a constant, we have to find the integral of 4 over x cubed plus kx with respect to x. And to do this, we can first of all rewrite 4 over x cubed in the form of regular indices. That means we can rewrite 4 over x cubed as 4x to the minus 3. So we have the integral over here of 4x to the minus 3 plus kx with respect to x. Okay, so to do this, well, we add 1 to the power divided by the new power. So adding 1 to the power, we have x to the minus 2, and dividing by the new power, the integral of 4x to the minus 3 is minus 2x to the minus 2. Integrating kx, if we add 1 to the power, we have x squared. Dividing by the new power, the integral of kx is a half kx squared. And because we have an indefinite integral, we add a constant c. Now for part B, hence find the value of k such that the integral from 0.5 to 2 of 4 over x cubed plus kx squared with respect to x is equal to 8. Well, over here we have the integral from 0.5 to 2 of 4x to the minus 3 plus kx, okay, with respect to x. And we've just found what this is. Obviously, all this is equal to 8. We've just found what this integrand turns out to be. That is minus 2x to the minus 2 plus 1/2 k x squared. And we do this in between the limits of 0.5 and 2. And all this is equal to 8. So, if we work out our upper limit, for our upper limit we have minus 2 lots of 2 to the minus 2 plus 1/2 k lots of 2 squared. For our lower limit we have minus 2 lots of 0.5 to the minus 2 plus 1/2 k lots of 0.5 squared. And we know that this is equal to 8. So for the first bracket, here we have minus 1/2. So we have minus 1/2 plus 2k for the first bracket, and for the other bracket, here we have minus 8, and here we have an 8th k squared. So we have an 8th k, and this is equal to 8. So with that being said, minus 1/2 minus 8, that's 15 over 2. So we have 15 over 2, and then 2k minus an 1/8 of k, that's 15 over 8k, and this is equal to 8. So we have over here 15 over 8k equals 1/2, and therefore multiplying by 8 then divided by 15, we see that k is equal to 4 over 15. For question 4, a tree was planted in the ground and its height h meters was measured t years after planting. Exactly 3 years after planting, the height of the tree was 2.35 meters. Exactly 6 years after planting, the height of the tree was 3.28 meters. Using a linear model, we have to find an equation linking h and t. Well, over here, the equation will be of the form h equals mt plus b, where m is the rate of growth, b is the original height of the tree. Now, we've got two statements here. We've got some time and some height. We've got another time and another height. So with this, we can form two equations and solve them simultaneously to find out the values of m and b. And with that, we can form an equation. With the first statement, t is 3, h is 2.35. So using that piece of information, we have 2.35 equals 3m plus b. And with the second statement, t is 6, h is equal to 3.28. Sorry, this is b just smudged out there. So we have 3.28 equals 6m plus b. So with that being said, if we subtract these equations, so if I call this equation 1 and the second equation 2, if we subtract these equations, 3.28 take away 2.35, that's 0.93. And 6m take away 3m, that would be 3m. And b minus b, that's 0b. 3m is equal to 0.93. m is equal to 0.31. So with that being said, when m is equal to 0.31, we can find out the corresponding value of b. If we substitute this into the first equation, we have 2.35 equals 3m. 3m is 0.93. plus b, we can conclude over here b is equal to 1.42, and therefore h is equal to the growth rate 0.31 t plus the original height of the tree 1.42. And now for part B, the height of the tree was approximately 140 centimeters when it was planted. We have to explain whether or not this fact supports the use of a linear model in part A. So now for part B, to explain this sort of statement, we first of all need to recognize over here that this 0.31 corresponds to the rate of growth. So let's just write that down. We have the rate of growth, and this 1.42 would represent the original height of the tree. So with that being said, we see that this 140 centimeters, which by the way is equal to 1.4 meters, so the 140 centimeters, which is equal to 1.4 meters, this is approximately 1.42 meters. And therefore, because this 1.4 is close to the original height, remember this 140 is the height of the tree when it was first planted, we can say that this fact supports the use of a linear model. So let's just write that down. We have supports the use of a linear model. Okay. For question 5, we have y, which is equal to 3x squared plus 24 over x plus 2, where x is greater than 0. We have to find in its simplest form dy over dx. So for part A, first of all we have y equals 3x squared plus 24x to the minus 1 plus 2. The first thing we do is we find dy over dx. Differentiating 3x squared, that would be 6x. Differentiating 24x to the minus 1, that would be minus 24x to the minus 2. And that's all we have to do. But for part B, we have to find the exact range of values of x for which the curve is increasing. Now, if the curve is increasing, this tells us that dy over dx is greater than 0. So with that being said, if dy over dx is greater than 0, what we have over here then is 6x minus 24x to the minus 2 being greater than 0. So if we multiply through by x squared, we have 6x cubed minus 24, this is greater than 0. Dividing through by 6, x cubed minus 4 is greater than 0. And therefore we can conclude over here x is greater than the cube root of 4. For question 6, part A, we have over here figure 1, which shows a sketch of the triangle ABC with AB equaling 3x, AC equaling 2x, and the angle CAB equaling 60 degrees. Given that the area of the triangle ABC is 18 root 3 centimeters squared, we have to show that x is equal to 2 root 3. Now, it's quite important to know over here that if I write it down, the area of a triangle is equal to a half AB sine C. In other words, a half times by a length times by length with an angle in between those lengths. So with that being said, what we have over here then, we have a half times by 2x times by 3x multiplied by sine 60 and we know that the area over here is equal to 18 root 3. Now, sine 60, that's root 3 over 2. So we have a half times by 2 times by 3 times by x times by x times by root 3 over 2. So we have 3x squared multiplied by root 3 over 2. This is equal to 18 root 3. So the root 3's cancel on both sides. So we have, if I rearrange, 18 divided by 3 over 2, that's 12. X squared is equal to 12. X therefore will equal the square root of 12. So we have root 4, root 3, and therefore x is equal to 2 root 3, which is what we wanted to show. And now for part B, hence find the exact length of BC, giving your answer as a simplified set. Well, if we know over here AC is 2x, 2 times by 2 root 3, that would be 4 root 3. So just add this to the diagram. 3 times by 2 root 3, that's 6 root 3. And we want to find the length BC. And we can do that using the cosine rule. The reason being we have an angle in between two lengths, we're finding the length opposite to that angle. So the cosine rule, let's just write this down. The cosine rule tells us that a squared is equal to b squared plus c squared minus 2bc times by the cosine of a. So using that, what we have over here, and it's quite straightforward, we have over here bc squared, which is equal to 6 root 3 squared plus 4 root 3 squared minus 2 lots of 6 root 3 lots of 4 root 3 multiplied by the cosine of 60 degrees. So if we grab our calculator, what do we have over here? We have over here, if I type all this in, we have 6 root 3 squared plus 4 root 3 squared minus 2 lots of 6 root 3 multiplied by 4 root 3 multiplied by the cosine of 60 degrees, the result of which is 84. So that's BC squared, and therefore BC is equal to the square root of 84. So we have root 4 root 21, therefore BC is equal to 2 times by the square root of 21. So over here we have 2 root 21. Okay. Question 7. The curve C has equation y equals k squared over x plus 1, where x is a real number and x doesn't equal 0. K obviously here is a constant. Now we have to sketch C stating the equation of the horizontal asymptote. Now if I grab a pencil and try to explain this, if I just draw just a regular graph of a number over x, so here we have y, here we have x. What we have over here, which I've just drawn, this is the graph of y equals a over x squared, sorry, y over a, just rub this out, where a is just a number. Okay, now over here we have a horizontal asymptote at y equals 0, but here we've moved the graph 1 unit up, and therefore when we come to sketch the graph for part A, just write this down. For part A, to sketch the graph of y equals k squared over x, we have over here, if I just draw on a quick set of axes, something like that, we have over here our x and y, and what we need to do, if we move the graph 1 unit up, so if we move the graph 1 unit up like so, we have y equals 1, and then if we move this graph up 1 unit up, we end up with the following graph, something looking like that. Okay, so this is y equals, well, here we have y equals k over x squared plus 1. We have k squared over x plus 1 shown over here. Now for part B, we have a line which has equation y equals minus 2x plus 5. We have to show that the x coordinate of any point of intersection of L with C is given by a solution of the equation 2x squared minus 4x plus k squared equals 0. Well, to do this, we simply equate equation 1 with equation 2. And doing so for part B, if we equate those equations to each other, we have k squared over x plus 1 equals minus 2x plus 5. And if I multiply through by x, we have k squared plus x equals minus 2x squared plus 5x, and rearrange it, we can therefore see 2x squared minus 4x plus k squared is equal to 0. Now for part C, hence find the exact values of k for which L is a tangent to C. And if L is a tangent to C, the discriminant b squared minus 4ac is equal to 0. So with that being said, if we state the values of a, b and c, a is equal to 2, b is equal to minus 4, c is equal to k squared. And if we substitute these into the discriminant, what we have over here then for part C, we have b squared, so we have minus 4 squared, minus 4ac, so we have minus 4 lots of 2 lots of k squared, and this is equal to 0. 16 minus 8k squared is equal to 0. 8k squared is equal to 16. K squared is equal to 2. K is equal to plus or minus the square root of 2. Question 8. We have to find the first 3 terms in ascending powers of x of the binomial expansion of 2 plus 3x over 4 to the power of 6. So to do this question, if we go to our formula book and if we scroll down over here somewhere, underneath the binomial series, we've got over here, and it's a bad attempt of a highlight, we've got over here the equation for a binomial series. So with that being said, if we were to do this question, for part A, we have over here 2 plus 3x over 4 to the power of 6, and this is equal to, for our first term, we have 6 choose 0 multiplied by 2 to the power of 6 lots of 3 over 4. Okay, this wasn't the best way of writing this. We have 3x over 4 to the power of 0. For our next term, 6 choose 1, lots of 2 to the power of 5, lots of 3x over 4 to the power of 1. And for our next term, 6 choose 2, 2 to the power of 4, 3x over 4 to the power of 2. We have as well higher order terms. So if we work all this out, let's grab our calculator. For our first term, let's just get rid of all this. We have over here 6 choose 0. We multiply this by 2 to the power of 6, and then we multiply this by 3/4, so 0.75 to the power of 0. We end up with 64. So that's our first term. For our next term, let's just replace this with a 1, and let's replace this with a 5, and let's replace this with a 1. We have 144 x, and if we replace this with a 2, this with a 4, and this with a 2, we have 135 x squared plus higher order terms. Now for part B, we have to explain how we could use our expansion to estimate the value of 1.925 to the power of 6. You do not need to perform the calculation. Well, all we do over here, we simply equate the 1.925 with the 2 plus 3x over 4. So for part B, let's just write that down. We have 2 plus 3x over 4 equals 1.925, and if we rearrange, we see that 3x over 4 is equal to 1.925 minus the 2, which is minus 0.075. 3/4, that's the same as 0.75. We see over here x is equal to minus 0.1. So with that being said, all we have to do in this question is explain what we will do. We would simply find the value of 64 plus 144x plus 135 x squared, etc., with the value of x being minus 0.1. That's all we do. Question 9. A company started mining in Riverdale on the 1st of January 2019. A model to find the total mass of tin that will be mined by the company in Riverdale is given by the equation T equals 1200 minus 3 lots of n minus 20 squared. T over here is the tons, where T over here is the total mass in tons, and n is the years after the start of mining. Using this model for part A, we have to calculate the mass of tin that will be mined up to the 1st of January 2020. And that's quite easy. For part A, we simply substitute in n equals 1 into this formula. So we have T equals 1200 minus 3 lots of 1 minus 20 squared. Just underline this. So if we work this out, let's grab our calculator. We have 1200 minus 3 lots of 1 minus 20 squared. We end up with 117 tons. Okay. Now for part B, we have to deduce the maximum total mass of tin that could be mined. Well, over here, we can essentially look at this equation for T, and we notice that this is in a form which has been, this is in a complete the square form, if you want to think of it like that. And so therefore, our maximum point over here would have coordinates 1200, our maximum point over here would have coordinates 20, 1200. And the reason for this maximum rather than a minimum is because we have over here a negative quadratic, because we have a minus 3 multiplied by an n squared, which is negative. And therefore we can conclude over here that the maximum total mass is equal to 1200 tons. For part C, we have to calculate the mass of tin that will be mined in 2023. So here we're just looking at the mass in 2023. So it's a bit tricky how we think about this question. But essentially what's happening over here is, if you think about it, this formula tells us the mass up to a certain number of years. And so if we want to determine the mass in 2023, we have to find the mass up to 2024 and then up to 2023, and the difference between those will tell us the mass in 2023. So if we consider the year 2024, well, over here let's just write that down. The mass in the year 2023, this will equal the mass up to 2024 minus the mass up to 2023, because up to 2023 we're on the 31st of December 2022, if that makes sense. And so the difference between these tells us the mass in 2023. So with that being said, all we have to do over here then is from 2019 to 2024, that's 5 years. So we have to work out T of 5, and then we subtract off up to 2023, that's when n is 4. So we have over here then 1200 minus 3 lots of 5 minus 20 squared, and then we subtract off 1200 minus 3 lots of 4 minus 20 squared. So if we work this out, so let's grab our calculator, we have 1200 minus 3 lots of 5 minus 20 squared. So this is 525. So we have 525 minus, and then if we change this to a 4, we have, and therefore the mass in 2023 is 93 tons. Now for part D, we have to state, giving reasons, the limitation on the values of n. So to do this, I think it's best if we draw the actual graph of t versus n, which I'll do right now. So having drawn the graph of t versus n, we have over here a negative quadratic, and the maximum point is at 1200. It crosses at 0, and through symmetry it would also cross through at 40, and you can work that out. But over here, this formula of t tells us the total mass including previous years. So for example, if we consider 2023, then, well, if we consider up to 2024, then we've added up the masses of the previous 5 years. So essentially we see that the mass will always increase. So hopefully that bit makes sense. And if you actually take a look at the graph is increasing up to n equaling 20. But beyond that, the graph starts decreasing, which doesn't make any sense, because no matter, even if in an individual year the mass of tin that we mine might be less than the previous year, overall cumulatively we should have an increase, but the graph doesn't show this. So the model is only valid for n being less than or equal to 20 to predict t. When n is greater than 20, t decreases, which doesn't make sense, and we see that after 40 years t becomes negative as well, if you want to write that down. Question 10. A circle C has equation x squared plus yx plus y squared minus 4x plus 8y minus 8 equals 0. We have to find the coordinates of the centre C and the exact radius of C. Well, an equation of a circle, I'll just write this down. That's of the form x minus a squared plus y minus b squared equals r squared. And the centre over here will equal a, b. So with that being said, what we have to do over here, to get this into this form, we would have to complete the square. So if we consider just the x's, for part A, we have x squared minus 4x, so half of minus 4, that's minus 2. So we have x minus 2 squared minus the square of 2. In terms of the y's, we have y squared plus 8y, half of 8, that's 4. So we have y plus 4 squared, then we subtract off the square of 4, and then we have minus 8. This is equal to 0. So we have x minus 2 squared plus y plus 4 squared. We have minus 4 minus 16 minus 8, which is minus 28, and this is equal to 0. So we have x minus 2 squared plus y plus 4 squared equals 28 as our equation for C. So when we come to find out the centre has coordinates 2, minus 4, and the radius will equal the square root of 28. The square root of 28 is root 4, root 7, which is 2, root 7. And now for part B, we have a straight line with equation x equals k, where k is a constant, and this equation is a tangent to C. We have to find the possible values of k. Well, if we have x equals k, what this means over here is, we have a vertical line, and if it's a tangent to C, this vertical line touches the circle once. Now, there's two ways to do this. One of those ways is really long, which I'm not going to cover. We could substitute in x equals k into this equation and then use a discriminant, but that would take far too long. But it's easier if we just simply sketch the circle and actually see what's going on. So let's just quickly do that. So if we actually draw those vertical lines touching the tangent exactly, touching the circle once, we have something which looks like this, and also crosses here, so looks like this. Okay, let's just fill this line up. So the important thing to notice over here, that this line over here, this x equals something, will equal 2 plus 2 root 7. The reason it's plus 2 root 7 is because we're going to the right from this x coordinate of 2. And this point, or this equation, will be x equals 2 minus 2 root 7, for a very similar reason, in that we're going to the left this time. So let's just complete this line. So in terms of what our values of k are, let's just grab a pen. The values of k will either equal 2 plus 2 root 7 or 2 minus 2 root 7. Question 11. We have f of x which is equal to 2x cubed minus 13x squared plus 8x plus 48. We have to prove that x minus 4 is a factor of f of x. Now to do this question, it's quite easy. It's easy in the sense that all we have to do over here, if we substitute 4 into f of x and we get a value of 0, we can then conclude that x minus 4 is a factor of f of x. So for part A, we have over here f of 4, which is equal to 2 lots of 4 cubed minus 13 lots of 4 squared plus 8 lots of 4 plus 48. 2 times by 4 cubed, that's 128, minus 13 times by 4 squared, which is minus 208. 8 times by 4, that's 32. And then we have the plus 48. So we end up with 0 if we add all these terms together. And since f of 4 is equal to 0, we can therefore conclude that x minus 4 is a factor of f of x. Now for part B, we have figure 2 over here. Well, sorry, we have to hence deduce the using algebra to show that the equation f of x equals 0 has only two distinct roots. Well, over here, essentially what's going on over here is, well, I'll do this on a separate page completely. What's going on over here is we've got our cubic for part B, 2x cubed minus 13x squared plus 8x plus 48, and this will equal our linear factor x minus 4 multiplied by our quadratic factor ax squared plus bx plus c. So the reason I'm doing this is because I want to see if this can be simplified any further, and if I get two roots from this, then we can conclude that we've only got two distinct roots. So we can find the values of a, b and c by, first of all, over here we can compare coefficients. So comparing coefficients, we have over here, if we compare the x cubes, on the left hand side we have two of them, and on the right hand side x times by ax squared gives an x cubed term. So we have 2 equals a is equal to 4. Comparing the x squared terms, I'll do this in blue. On the left hand side we have minus 13 of them. On the right hand side, x times by bx gives an x squared term. Minus 4 times by ax squared gives an x squared term. So we have over here minus 13 equals b minus 4a. A is a is equal to 2. So we have minus 13 equals b minus 4 lots of 2. Minus 13 equals b minus 8. Therefore, b we find to be minus 5. And if we compare the numbers, on the left hand side we have 48 of them, and on the right hand side we have c of them. We have minus 4c of them. So we have 48 equals minus 4c, and therefore c is equal to minus 12. So with that being said, we can now conclude over here that f of x is equal to x minus 4 lots of ax squared, so we have 2x squared, plus bx, so we have minus 5x, plus c, so we have minus 12. And we can further factorize this over here. So if we consider 2x squared minus 5x minus 12, we need two numbers which multiply to give 2 times by minus 12, which is minus 24, which add to give minus 5. You'd find these two numbers to be minus 8 and 3. So we can rewrite this minus 5x in terms of what we've just found. We have 2x squared minus 8x plus 3x minus 12. If I split this down the middle, factorizing these two terms, we have 2x lots of x minus 4. And factorizing these two terms, we have 3 lots of x minus 4. So grouping the terms together, we see that we have 2x plus 3 lots of x minus 4. So therefore, f of x is equal to 2x squared minus 5x minus 12. This is equivalent to, well, we have a 2x plus 3 lots of x minus 4 lots of x minus 4. In other words, x minus 4 squared. And if we actually solve f of x equaling 0, we have 2x plus 3 lots of x minus 4 squared equals 0. So here we see that x is equal to minus 3 over 2, and here x is equal to 4. And this x equals 4 is our repeated root. So let's just write that down. Here we have a repeated root. Okay, and therefore we only have over here two distinct real roots to this equation. And if we go back to the question for part C, we have to deduce, giving reasons for our answer, the number of real roots to the equation 2x cubed minus 13x squared plus 8x plus 46 equals 0. Well, to do this, if I grab a pencil, before the graph crossed at 48, okay, and that makes sense. When x is 0, y is 48, that makes sense. And here, everything with this equation and this equation over here are pretty much the same, other than this 48 and this 46. So, essentially, instead of the graph crossing at 48, it's crossing at 46 in the y-axis. And therefore, what we have over here is a translation by vector 0, minus 2. So let's just write that down for part C. For part C, going from 2x squared minus 5x minus, that's incorrect. Sorry, I didn't realize I should have put this over here instead. But what we have over here then, if I just correct this, we have our original graph, 2x cubed minus 13x squared plus 8x plus 48, and now we're going to 2x cubed minus 13x squared plus 8x plus 46. This over here is a translation by vector 0, minus 2. So in terms of the actual graph, what this means over here then is the graph over here, I'll rather do this in pencil, the graph is essentially moving 2 units down. So we have something which looks like this, okay? And you'll notice over here, if I grab a fill tip, this graph over here crosses at 1, 2, 3. It crosses at 3 distinct real points. So let's put over here that the graph crosses at 3 distinct real points. Okay. Now for part D, given that k is a constant and the curve with the equation y equals f of x plus k passes through the origin, we have to find the two possible values of k. Now over here, if I actually show on the roots, here we have minus 3 over 2, and here we have the 4. Now, if the graph passes through the origin, there's two situations which could arise. The first one is that this graph, this point over here has moved, I don't know how clear it is, but this graph over here has moved 3 over 2 units to the right. That's one case. The second case is that this minus 4 has moved 4 units to the left. And in terms of what this means in terms of our translation, because over here, remember, if I write this down, going from y equals f of x to y equals f of x plus k, this would be a translation by vector minus k 0. Okay, so in terms of our possible values of k could either equal minus 3 over 2, because remember, we use the opposite sign. So because it's going 3 over 2 units to the right, k will equal minus 3 over 2. Or if it's going minus 4, or in other words 4 units to the left, k could either equal 4 as well. So therefore our possible values of k will either equal minus 3 over 2, or k could equal 4. Question 12. We have 10 sine squared theta minus 7 cos theta plus 2 over 3 plus 2 cos theta, and we have to show that this is equivalent to 4 minus 5 cos theta. And to do this question, we have to make use of the identity, that is sine squared theta plus cos squared theta equals 1, which we can rearrange to say that sine squared theta is equal to 1 minus cos squared theta, and that cos squared theta is equal to 1 minus sine squared theta. So we're going to replace the sine squared theta with the 1 minus cos squared theta, so that we have an equation on the left hand side which is in terms of cos. And doing so, well, instead of writing sine, I'm just going to write s, and in terms of cos, I'm just going to write c. So what do we have over here then? We have over here 10 sine squared theta minus 7 cos theta plus 2 over 3 plus 2 cos theta. Now, the trick is with these sorts of questions, we start on one side and try to get to the other side. Okay, so here I'm just going to start on the left hand side and try to get to the right hand side. So if I replace sine squared with 1 minus cos squared, we have 10 lots of 1 minus cos squared theta minus 7 cos theta plus 2 over 3 plus 2 cos theta. Okay, and if I expand this out, we have 10 minus 10 cos squared theta minus 7 cos theta plus 2 over 3 plus 2 cos theta. Okay, so if we simplify the top, we have minus 10 cos squared theta minus 7 cos theta plus 12, and on the bottom, just underline this, we have 3 plus 2 cos theta. Okay, now in terms of what this means, we can simplify the top by factorizing it. So if we consider over here minus 10c squared minus 7c plus 12, we require two numbers which multiply to give minus 120, which add to give minus 7. Those two numbers would be minus 15 and 8. So in terms of what this means, if we rewrite the minus 7c in terms of what we've just found, we have minus 10c squared minus 15c plus 8c plus 12. So if I split this down the middle, factorizing, we have minus 5c lots of 2c plus 3, and here we have 4 lots of 2c plus 3, and therefore grouping the terms together, we have 4 minus 5c lots of 2c plus 3. Okay, so what we can do now is we can rewrite the top in terms of what we've just found. So we have over here 4 minus 5 cos theta, lots of 2 cos theta plus 3 over 3 plus 2 cos theta. Okay, and happily for us, the 3 plus 2 cos thetas cancel, so we end up with 4 minus 5 cos theta. Okay, and now for part B, hence or otherwise solve for x being in between 0 and 360 degrees, the equation 10 sine squared x minus 7 cos x plus 2 over 3 plus 2 cos x. Now, if we use what we've just found in part A, we know that this left hand side is equal to 4 minus 5 cos x. So let's just write that down. We have 4 minus 5 cos x, and this is equal to 4 plus 3 sin x. Okay, so hopefully that makes sense. And happily for us, the 4's cancel on both sides. So if we simplify this a bit, we have minus 5 cos x equals 3 sin x. Okay, and if we rearrange, we see that sin x over cos x is equal to minus 5 over 3. Sin x over cos x, that's tan x. So tan x is equal to minus 5 over 3. And if we solve for values of x, if we grab our calculator, if we find the inverse tan of minus 5 over 3, we end up with minus 59.036, etc. Our next value, if we add 180, we end up with 120.963, etc. And if I add on another 180, we have 300.963, etc. And therefore the values of x, we have 121 and 301 to the nearest whole number. Okay. For question 13, we have figure, what figure do we have? We have figure 13 over here, which, figure 3, sorry, which shows a sketch of part of the curve with equation y equals 2x cubed minus 17x squared plus 40x. The curve has a minimum turning point at x equals k. The region R, shown shaded in figure 3, is bounded by the curve, the x-axis and the line with equation x equals k. We have to show that the area of R is 256 over 3. Well, we've got our equation for y, and the first thing we can do over here is find out the value of dy over dx. The reason being, whenever we see this words like minimum turning point, we should be thinking to ourselves, dy over dx is equal to 0. So if we find dy over dx and set that equal to 0, and then solve for values of x, we can find out the x coordinate of the minimum point. So dy over dx is equal to 6x squared minus 34x plus 40, and if we set that equal to 0, dy over dx equals 0, we have 6x squared minus 34x plus 40 equals 0. So we have x equals minus 34 plus or minus 34 squared minus 4 lots of minus 34 lots of 40. This bit over here is square rooted, and the bit on the bottom, that would be 2 lots of 6. So what we see over here then is that our possible values of x, if we solve on the calculator. So press shift, no we don't, we press menu. Equation slash function, we have a polynomial of degree 2 with coefficient 6, minus 34 and 40. We end up with 4 and 5 over 3. So let's just import that in. Here we have 5 over 3 and 4. Now in terms of what this means in our diagram, this over here corresponds to our maximum, and this over here, where x is equal to k, this over here corresponds to our minimum. So with that being said, this maximum corresponds to the 5 over 3, and this 4 corresponds to the minimum, and therefore we can conclude over here that k is equal to 4. So let's just write that down. K is equal to 4. So what does that mean? To find the area of R, we integrate the curve in between the limit 0 and this value of k, which is 4. So let's do that. So we want to find over here the integral between 0 and 4 of 2x cubed minus 17x squared plus 40x with respect to x. So integrating 2x cubed, that's a half x to the 4. Integrating minus 17x squared, that's minus 17 over 3 x cubed. And integrating 40x, that's 20x. And we do this in between the limits 0 and 4. So for our upper limit, we have a half lots of 4 to the 4 minus 17 over 4, sorry, minus 17 over 3 lots of 4 cubed plus 20 lots of 4, and for our lower limit we have 0 minus 0 plus 0. And if we work this out, so let's just grab our calculator again. We have over here, if we substitute 4 into that, we have a half lots of 4 to the power of 4 minus 17 over 3 lots of 4 cubed, and then we have 20 lots of 4 squared. So this should be squared. So working that out, we get 256 over 3, which is what we wanted. So here we have 256 over 3, which is our final answer. Question 14. The value of a car V pounds can be modelled by the equation V equals 15,700 e to the power of minus 2.5t plus 2,300, and t is the age of the car in years. Using the model, we have to find the initial value of the car. That's quite straightforward. That's simply when t is equal to 0. So when t is equal to 0, V is equal to 15700 e to the 0 plus 2,300. The value of the car initially is £18,000. For part B, for the first part, given that the model predicts that the value of the car is decreasing at a rate of £500 per year at the instant when t is equal to capital T, we have to show that 3925 e to the minus 0.25t is equal to 500. Well, over here, if it's decreasing at a rate of minus 500, dy over dx is equal to minus 500. Well, sorry, dv rather over dt is equal to minus 500. Now, we know what v is. we can differentiate this formula for v to find out what dv over dt is at this point t equals capital T. So dv over dt at this instant when t is equal to capital T, if we differentiate by multiplying by the differential of the power, so if we multiply 15700 by minus 0.25, we have the differential being minus 0.25 multiplied by 15700 e to the minus 0.25 capital T. And we know that this is equal to minus 500. Now the minuses cancel on both sides. A quarter of 15700, that's 3925. So we have, of course, 3925 e to the minus 0.25t, which is equal to 500. And for the next part, hence find the age of the car at this instant, giving an answer in years and months to the nearest month. If we solve this equation, taking logs of both, well, if I divide through by 3925, we have e to the minus 0.25t equals the natural log of 500 over 3925. So, sorry, we don't have we've not taken logs. And now if we take logs of both sides, we have minus 0.25t equals the natural log of 500 over 3925. So if we solve for t, we have the natural log of 500 over 3925 divided by minus 0.25. So if we work this out, we have the natural log of 500 over 3925, and if we divide this by minus 0.25, we end up with a value of 8.242, etc. So therefore we have 8 years and 3 months. Okay, now for part C, we have to state the value of A. Well, if we go back to the original equation, if I sketch V versus T, so if I just quickly sketch that, like so, then essentially we've got an asymptote over here at 2300, and we've got a negative exponent like that. So this is V equals 15700 e to the minus 0.25t plus 2300. And essentially we see that this value approaches but never reaches 2300. And therefore we can conclude over here that the value of A is equal to 2300. So that's part C. The value of A is equal to 2300. And now for part D, stating a limitation of this model, I'll do part D over here. The limitation of the model is that the price of the car could become rare, for example, as the car gets older. So let's just write that down. The price of the car may rise as the car becomes old. For question 15, given that n is a natural number, we have to prove over here that n cubed plus 2 is not divisible by 8. Now, to do this question, n over here, if it's a natural number, it can either be a positive odd number or a positive even number. And we'll consider both cases separately. If we consider the case when n is even, let's put this into focus. If n is even for some positive integer x, in other words, we can write n as 2x, then if we substitute that into this equation here, we have over here then 2x all cubed plus 2, which is the same as 8x cubed plus 2, and if I factorise out the 8, we have 8 lots of x cubed plus 2. And we see over here that this is 2 more than a multiple of 8, and therefore it's not divisible by 8. The second case is when n is a positive odd number. That is when n is equal to 2x plus 1. And if we substitute that n equals 2x plus 1 into n cubed plus 2, we have over here then n cubed plus 2, which is equal to 2x plus 1 cubed plus 2. Now, 2x plus 1 all cubed, we can rewrite that as 2x plus 1 lots of 2x plus 1 squared. So this should be squared. And then we still have this plus 2. So, if we expand out, if I just focus this, if I expand out 2x plus 1 squared, then we have 4x squared plus 4x plus 1. So we have 2x plus 1 lots of 4x squared plus 4x plus 1 plus this extra 2. And if we multiply all this out, 2x times by 4x squared is 8x cubed. 2x times by 4x, that's 8x squared. 2x times by 1, that's 2x. 1 times by 4x squared, that's 4x squared. 1 times by 4x, that's 4x. 1 times by 1, that's 1. We still have this extra 2. We end up with 8x cubed plus 12x squared plus 6x plus 3. And we see over here, if I factorise out a 2 from the first 3 terms, we have 2 lots of 4x cubed plus 6x squared plus 3x plus 3. And we see that this is in the form of an odd number because we have an integer multiplied by 2, which is even. Adding 3 to it makes it odd. And therefore, it's not divisible by 8. For question 16, we have 2 non-zero vectors a and b, which are such that the magnitude of a plus b is equal to the magnitude of a plus the magnitude of b. We have to explain geometrically the significance of this statement. Now, all this means is that the vector a and the vector b are in the same direction. Okay, and now for the next part, 2 different vectors m and n are such that the magnitude of m is equal to 3 and the magnitude of m minus n is equal to 6. The angle between the vector m and the vector n is 30 degrees. We have to find the angle between the vector m and the vector m minus n, giving your answer in degrees to 1 decimal place. Well, if we actually draw out what's going on, first of all, if we draw the vector m, looks something like that, and the vector m minus n, well, first of all, to draw that, we need to draw the vector minus n. And that looks something like that. Okay? And therefore, the vector m minus n goes over here. We have here m minus n. And we know already that the angle between m and n is 30 degrees. So let's just add this over here. And we're finding the angle between m and the vector m minus n. We'll call it theta. Now, if I draw this triangle again, as neatly as I can, we have something which looks like this. We have over here the vector m, which is, the magnitude of that is 3. We have over here the 30 degrees, theta here. And this is 6. For us to find this value of theta, there's a couple of things we need to know. Normally we can use the sine rule if we've got an angle and a length opposite it. But for this theta, we don't have a length opposite it. Now we can find... No, we can't. The easiest way to do it, if we consider this 3 the angle opposite it, we'll call this alpha. We can find out what alpha is and then use the fact that angles in a triangle add up to 180 to find theta. Now, we need to use the sine rule. That is, sine A over A equals sine B over B equals sine C over C. So using that, we can find the angle alpha. That is sine alpha over 3 equals sine 30 over 6. So if we rearrange for sine alpha, we have a half divided by 6, that's a 12th. Multiplying that by 3, we have 3 over 12, which is 0.25. And therefore we can find out the angle alpha if we take the inverse sine of 0.25. We have 14.5 to 1 decimal place. And therefore the angle theta is equal to 180 minus 30 minus 14.5, the result of which is 135.5 degrees. So theta is equal to 135.5 degrees, which is our final answer. Now, that concludes the end of this paper. Don't forget to like, share and subscribe. And if there are any questions, please feel free to comment in the comment section below. And I'll see you guys in the next video.